Hello, my beautiful bee friends. I hope everyone is doing well. We are going to jump in right now with the Hive monitoring project. So with that, I'm going to go ahead and start grabbing parts pieces. I'll tell you what they are. We'll go through all the stuff up front first, and then I'm going to take a quick pause, pull everything from the back to the front, and then we'll review those items as well. So starting off with number one here, this is going to be the ESP32 board. This is the brains of the whole project. Each hive is going to get one of these to read data from the sensors, and it will save that and later send it to the collector node, which is going to be this Raspberry Pi right here. This is a Raspberry Pi 4, but we're going to take all the data from each of the ESP32s, send them up to the Raspberry Pi, and that's what's going to publish everything to the web. So we'll go into more detail with each of these later on, but this is a Raspberry Pi 4 that we're using. Over here, these are going to be card readers. This is just a micro SD card reader, and that's going to be used to store data locally. And of course, we've got the actual SD cards here as well. The brand doesn't really matter. Find some that work for you. These are pretty cheap. Everything that's here is going to be linked down in the description. The alligator clips are from Harbor Freight. These are optional. You might need some of these, particularly the ones here at the bottom. Not so much the larger ones unless you're connecting directly to a battery. So right over here, these are the actual sensors. I got a couple of them that are in a shorter package here with only 5 of them. And then these are the 15 packs here. But these are the sensors that are going to be monitoring all of the temperature for us. Now, in real life, we're not going to actually need to generate heat. We're going to have bees in there. But as part of our kind of initial setup and testing, we've got these heat generating strips. So these strips are going to give us the simulated cluster movement throughout the winter. This package right here and this tiny little guy right here, this is the BME280 sensor module. So this is going to measure humidity, air pressure, temperature inside the hive, and that's what's going to tell us kind of what's going on in the overall hive environment. This guy right here is a 12 volt to a 5 volt converter. This is going to downgrade the voltage a little bit for us. We're going to need one of these for every hive. I only have one right now just to kind of keep costs down. Now in these packages here, you're going to see these particular wiring blocks. You've got these wiring blocks, and you've got these. These are all different types of blocks that we're going to use to tie the wiring in for these sensors so that we can do all the actual temperature monitoring. Different ones are kind of for different purposes. We'll get into the details of that later. Some of them don't need as much as others. So while we might use this on one that might have the heat generators and the sensors, we might just use these on the others. And we'll talk more about that in detail later on. Now here in the front, we've got, these are just going to be jumper wires that are used for doing test connections. So as you see here, I've got, this is that little temperature monitor probe here for the temperature, humidity, air pressure. You see how we have that wire connected into that? We're going to be putting those into these right here, which are called breadboards. And this is how we're going to be doing all of our initial electronics testing. We're going to wire everything through these breadboards, make sure it works, prove that everything is electrically doing what it's supposed to do, and then we'll actually solder it onto the boards. Now up front here, we have some heat shrinks. So everything that is electrical that is not kind of hardwired, like for example, if I need to, I can't use these as they are. I'm going to have to hook up longer electrical supply lines to these. So I'll solder these on, and then I'll put the shrink wraps on underneath of those, and that way it'll help to protect those. I'm going to use the heat gun here. This is a Wagner. It doesn't matter what brand you use, but I have this Wagner heat gun. It'll actually give you the heat to shrink these up. Some people that don't have the shrink guns or the heat shrink guns, they'll just use a lighter or whatever. You can do that, but you can also run the risk of melting the plastic or damaging the insulation. So I really recommend not using that if you can avoid that. Now just above this here, you'll see where we do have the 2 breadboards. I've got a larger one and a smaller one. I have a bunch of these at different sizes. They're really handy. These are magnifying glasses that go on a regular style glasses type of setup with a light on it. I have a link in the description to the full thing. I don't have the headpiece for it right now. Now over here we have a micro screwdriver set. This is going to be important for dealing with all the little screws that you see on this guy right here. Lots of little tiny screws in there. And you'll see that across all of these items have small screws. Now up here we have this is going to be an aluminum bus bar. I'm going to have a positive and a negative aluminum bus bar. I don't recommend using aluminum. These were free, so I'm using them because they were free. This is all very low voltage, but we're going to hook up, for example, the positive cable here on this end, and then we'll hook up all the positive lines for all the project will run into here within the box. Same thing on the opposite side with all of the negatives. Your ground cable from the battery will come in right here, and then all these other connections will have all of the ground connections for the other devices. You'll see here in the back, I've got these large battery clamps here. These are going to be what actually connects to the main batteries, and then we'll supply the bus bar that we just looked at from some of these screws off to the side. We got a lot of wire back here. There's a whole thing of 22 gauge wire. This is all 16 gauge wire behind that. And then right there, we've got the soldering iron. This is a great soldering iron. It is a little bit pricey. You don't have to buy the expensive one. Get whatever one works for you. But this one is really nice. I've been very pleased, very happy with it for a long time. And that's what we're going to be using for the project. Now up in the front, slightly out of view here, we'll zoom back out, see if we can bring it back into view. We've got some 4,700 4.7K resistors. These are going to be used in line to just support some changes that we might need in the voltage. More info about that later. We also have male to female alligator clip wires. These are going to be really handy for connecting up to batteries to bring power in for different devices and things, and we'll see some more of that later on. So a quick, just lightning round explanation of everything we have here. We've got the ESP32 board, we've got a Raspberry Pi, we have a micro SD card reader, the actual cards themselves, temperature sensors, temperature or heat generators. We have multiple connecting blocks to bring the wiring into the ESP32. We have a voltage transformer, basically taking 12 volts down to 5 volts. Breadboards, jumper wires, heat shrink tubing, and a heat gun. Micro screwdriver, soldering iron, magnifying glasses, spare wire, bus bars, and battery connections. Now from here, I'm just going to pick us up and move us back a little bit here, and we're going to zoom in on the back row. Okay, on the back row, I've got 4 items back here. On the top is a light. This is actually a really bright work light. You're going to need that in conjunction with these magnifying glasses here or some other type of magnifier to do some of the soldering work. Unless you're young and you still have great eyes, then by all means just do it, do it however you can do it. But having a light like that is really going to come in handy to allow you to see all the components and make sure you're getting good solder connections. Now right in the middle here we have a multimeter. This one is by Proster, P-R-O-S-T-E-R. It's the model VC99, Victor Charlie 99. It doesn't matter which one you get. You can buy one from Harbor Freight, you can buy one from somewhere else. The cheaper ones that you get aren't going to be as accurate, they're not going to last as long generally. I have some Klein, I have some Fluke. The Proster is more on the lower end of what I have. But what we're going to basically be doing for the most part is we're checking voltage, resistance, continuity, it's just some real basic functions. Now on the left here, this is a power supply, or a power, just a regular DC power supply. I got this for, I think it was about $60 when I got it. Now they're going for about $75. The one thing that differentiated this one from a lot of the other ones is this one actually has a USB-C adapter on it. So you can run power to USB-C or to USB if you wanted to be charging something while you're working with it. And so that's kind of cool. Or if you wanted to run power, like let's say for example, we could run USB directly into something like a Raspberry Pi or some other kind of component. If there is a component that will receive power via USB-C or at USB, you can run it right out of here. So that's kind of a cool thing to do as well. But this is very basic. It's 30 amps. I'm sorry, it's 30 volts, 3 amps. That's all you would need for a project like this. And it's going to be really great to give us the power we need to do the testing for various parts and pieces. Now, if you decide you want to go all in, you got a few extra dollars, and maybe you do some other projects, the Rigel DL3021, this thing is really, really cool. I can use it as a power generator, and I think it goes 40 amps. I can't remember the voltage. I want to say, I'm not sure off the top of my head on the voltage, but I know that the amperage goes to 40 amps. And what you can do with this is apply a power load. You can then simulate the introduction of resistance to various levels. You don't actually have to have a resistor like this here, you can just simulate, from point 1 to point 2, basically, that resistor is there. So it allows you to do a lot with that. I do a lot of battery analysis when I'm discharging batteries with that. But the primary purpose I'm going to be using it for on this project is making sure that we are able to fully track the power utilization of all these components during the project, while everything is up and running. So if I have all the temperature sensors online and we're generating heat and we're using, the Raspberry Pi is running, everything is up and running. How much actual power is it consuming, so that I can then size the solar panel, the battery, and all the other parts that go with, the charge controller and everything else. So this is pretty much everything that we're going to be using. This is absolutely subject to change. I am going to be kind of moving things around a little bit. And as I determine, maybe, for example, I think these blocks are a pretty good example. Like, I might need, 5 or 6 more of these. I bought a pack of 50 on these because some of them have 3 and some of them have 2 connectors. So I don't know that I'm going to need any more of these. So there's a lot of things that could change, but this is probably about the 95% solution for everything you'll need to follow along. Everything that is here is going to be linked in the description so that you can, again, get the parts and pieces and follow along with us. If you have ideas or thoughts or suggestions, drop a comment and let us know. Outside of that, we'll see you on the podcast. Take care, be kind to one another, and remember that I love you. There's nothing you can do about it. We'll talk to you soon.